There is a lake in Death Valley where stones move on their own. They weigh as much as a grown man, and they leave long, curving trails carved into the cracked mud behind them. For over 70 years, no human being had ever seen one move. Geologists argued about it. Some said hurricane winds, some said thick sheets of ice. And for decades, the honest answer scientists gave was the same one they still give about the places you are going to see tonight. We are not entirely sure. On the border between Chile and Argentina, there is a cave made of solid marble, and the walls swirl in patterns of blue and grey that look painted by hand. The entire cavern is floating on turquoise water, and it took the lake 6,000 years to carve it. You can only reach it by boat, and when the water level changes, the colors change with it. In the middle of the Sahara Desert, there is a target, a perfect series of rings, 50 kilometers across, so precise and so enormous that the first people to see it clearly were astronauts in orbit. For years, the leading theory was that a meteorite had struck the Earth here. That theory turned out to be wrong. And what actually made it is stranger than an impact. And in a single desert in the American state of Utah, there is a curve of stone standing entirely alone against the open sky, holding itself up with nothing underneath. There is no pillar, there is no support. Geologists can tell you the sandstone is soft and crumbling, that it should have collapsed long ago. They cannot tell you why it is still standing tonight. This is our countdown of the 15 most unreal rock formations on Earth, the ones that even geologists struggle to fully explain. Stay until the end, because number 1 is that impossible arch in Utah, and the reason it has not fallen is a question that gets harder to answer every single year. Before we begin, drop a comment and tell us where in the world you are watching from right now. We want to see how many countries this video reaches. Number 15. The Stone Forest of Shilin, Yunnan Province, China. From a distance, it looks like an army frozen in place. Thousands of grey limestone columns, some over 30 meters tall, standing shoulder to shoulder across an area of roughly 350 square kilometers. The local Yi people have a legend that these are the petrified remains of a heartbroken woman turned to stone. The geological story is almost as old as it is strange. This limestone formed on the floor of a shallow sea about 270 million years ago, during the Permian period, long before the dinosaurs. Then the land rose. Rain, faintly acidic, went to work on the stone for millions of years, dissolving vertical channels straight down through the rock in a process geologists call karstification. What is difficult to explain is the sheer regularity of it. Why the stone splits into these narrow, blade-like towers instead of eroding into rounded hills, the way most rock does, is still governed by the fine details of the original fractures, details that were locked into the stone before the first mammal ever existed. Walk into it, and the towers close over your head. The paths between them twist and fork until you lose all sense of direction, which is exactly why the Yi have used this place in their oldest stories as a border between the ordinary world and something older. Stand at the base of one of the tallest pillars and look up, and you are looking at roughly 10 stories of stone that was laid down grain by grain on a tropical seafloor, then lifted 3 kilometers into the air, then dissolved into a needle by nothing more violent than rainwater, given enough time. The Yi people had a name for this place for centuries. Science needed the theory of plate tectonics just to begin catching up. Number 14. The Giant's Causeway, County Antrim, Northern Ireland. 40,000 columns of dark basalt, most of them near-perfect hexagons, marching down from the cliffs and disappearing under the grey water of the North Atlantic. They fit together so cleanly that for centuries, people refused to believe nature had done it. The Irish legend says a giant named Finn McCool built it as a bridge to Scotland. The scientific explanation is that Around 60 million years ago, a vast sheet of lava cooled and contracted, cracking into these geometric shapes. But here is the part that stayed unsolved for 200 years. Why hexagons? Why not squares? Why not random shapes? In 2018, a team led by Professor Jan Lavallee at the University of Liverpool published a study in the journal Nature Communications. They melted rock from an Icelandic volcano and measured exactly when it fractured as it cooled. They found the columns lock into place at temperatures between roughly 840 and 890 degrees Celsius. The reason they found is that fast, even cooling generates a network of contraction cracks, and hexagons are simply the most efficient way for stone to relieve that stress, packing the surface with the least possible energy. Nature was not trying to make hexagons. It was trying to release tension, and hexagons were the answer it arrived at, the same answer a honeycomb arrives at. But knowing why does not make it feel any less deliberate when you are standing on them. The columns descend in tiers like a giant staircase, some knee-high, some taller than a person, and they run right down into the sea and vanish, so that no one has ever seen where the causeway truly ends. It took a modern laboratory, molten rock, and precision instruments to explain what a legend had already given a name. 40,000 hexagons, cut by nothing but cooling stone, still fitting together after 60 million years. Number 13. Wave rock. In the dry farmland of Western Australia, it is exactly what the name says. A wall of granite 15 meters high and over 100 meters long, curled forward at the top like a wave frozen at the instant before it breaks. It looks like it is about to crash down on you. The rock itself is ancient, part of a granite mass around 2.7 billion years old, nearly 2/3 the age of the planet. And the strangest thing about wave rock is that it was not carved by wind or by water on the surface. Geologists believe the smooth, overhanging curve was shaped underground, below the old soil line, where chemically active groundwater ate away at the base of the granite for millions of years. Only later did erosion strip away the soil and reveal the wave that had been hiding beneath it. The streaks of gray and red running down its face are mineral stains left by rainwater. The chemistry is subtle. Water sitting in the soil is slightly acidic, and where it pooled against the buried granite, it rotted the rock softer than the stone just above it. When the softer base was finally stripped away by erosion, the overhang was left leaning out over empty air. So you are looking at a wave that was sculpted in the dark underground and then uncovered. And it raises a question that sounds simple until you try to answer it. If the curve was carved below the surface, then the surface of the land here must once have been meters higher than it is today, and an entire layer of the world has quietly gone missing. What we still cannot say with certainty is exactly how long it stood buried before erosion set it free, or how much longer the wave will hold its shape before it, too, wears away. Number 12. The Eye of the Sahara, also called the Richat structure, on the Adra Plateau of Mauritania. It is a bullseye, a series of concentric rings, roughly 50 kilometers across, sitting in the flat emptiness of the desert. It is so large and so symmetrical that astronauts have used it as a landmark from space. When it was first studied closely, scientists were convinced it had to be an impact crater, a scar left by a giant meteorite. It was the only thing that seemed to make sense of such perfect geometry. But when they searched the rock for the telltale signs of an impact, the shocked quartz, the melted stone, the debris, they found none of it. The meteorite theory collapsed. What geologists now believe is that molten rock pushed up from below, warping the layers of sedimentary stone into a dome. Then erosion wore the dome away, and because the layers of limestone, quartzite and sandstone are different hardnesses, they wore down at different speeds, leaving these raised rings behind. Field expeditions eventually found the fingerprints of that internal process, igneous dikes where molten rock had forced its way up, and hydrothermal minerals cooked by heat from below. The structure is at least 100 million years old, and even now, the debate over exactly how it became so astonishingly circular, so cleanly ringed, when most eroded domes on Earth look nothing like this, has not entirely gone quiet. A small but stubborn group of researchers still argues the standard story leaves something unexplained. Stand in the center of it, and you would never know. You would see only low ridges of rock curving away in every direction, so vast that the roundness is invisible from the ground. It takes the view from space to reveal that you are standing in the middle of an eye 50 kilometers wide, staring back up at the people who came looking for a crater and found something they are still arguing about.
What you're seeing behind me is one of the most unique geological signatures on the planet. The erosion here tells a story millions of years in the making.
Number 11. The hoodoos of Bryce Canyon, Utah. A hoodoo is a thin spire of rock that rises from the floor of a dry basin, and Bryce Canyon holds the largest concentration of them anywhere on Earth. Tens of thousands of them, glowing orange and pink, packed so densely they look like a stone cathedral melting in slow motion. The Paiute people who lived here believed the hoodoos were ancient beings, frozen into rock as punishment. The force that makes them is deceptively gentle. Bryce sits high enough that the temperature crosses the freezing point around 200 times a year. Water seeps into cracks by day, freezes and expands by night, and slowly pries the rock apart, a process called frost wedging. Rain, slightly acidic, rounds off the rest. What is genuinely hard to predict is the shape of any single hoodoo. Each spire is a record of tiny differences in the hardness of the rock, layer by layer, and the harder caps of stone on top protect the softer rock beneath until, one day, they do not. Some stand alone like chess pieces. Others crowd together in walls and rows, striped in bands of white and orange that mark the different ancient muds they were carved from. And the light does something to them that no photograph fully captures. At sunrise, when the low sun hits the amphitheater, the whole basin seems to catch fire, thousands of spires glowing as if lit from inside. What the geologists genuinely cannot forecast is the timing. They know the whole forest of hoodoos is retreating into the cliffs at a rate of a foot or two every century. They cannot tell you which spire falls tomorrow and which stands for another 1,000 years. Every hoodoo you see is temporary. They are all very slowly falling down. Number 10. Tsingy de Bemaraha, Western Madagascar. The word Tsingy comes from a Malagasy phrase that means, roughly, to walk on tiptoes, and once you see it, you understand why. It is a forest of limestone blades. Thousands of grey stone needles, some reaching 100 meters into the sky, packed together with razor-sharp edges that can cut through skin and rope. There are canyons, between them so narrow and so deep that sunlight barely touches the bottom. This limestone began as coral on a seabed in the Middle Jurassic, well over 150 million years ago. When the land rose, tropical rain did the rest, dissolving the rock straight down along vertical cracks and leaving these knife-edge ridges standing. It became a UNESCO World Heritage Site in 1990. And here is what still astonishes biologists more than geologists. To cross it, researchers have to build bridges and bolt cables into the rock because there is no walking on ground that has been dissolved into a field of vertical knives. Rainwater still runs down through the maze into a hidden world below, where flooded caves and underground rivers carve the stone from beneath even as the rain carves it from above. So the formation is being eaten from two directions at once, top and bottom, which is part of why the ridges grow so impossibly thin and sharp. Inside this maze of blades, cut off from the outside world, Entire species of lemurs and reptiles evolved that exist nowhere else on the planet, leaping between the needles and living their whole lives on stone that would slice a careless human open. Number 9. The marble caves of General Carrera Lake on the border between Chile and Argentina. These caves are made of solid marble, and the walls swirl with veins of blue, grey, and white that look like brushstrokes. But the true magic is the light. The caverns sit at the water's edge, and the turquoise glacial water reflects up onto the polished marble ceilings, so the whole cave seems to glow from within, shifting in color as the seasons and the water level change. It took the lake more than 6,000 years of constant wave action to carve these hollows out of a solid peninsula of marble. You can only reach them by boat. What makes them difficult to fully pin down is that they are still being made. Every wave that laps against the marble is changing the shape of the cave very slightly right now. The blue veins in the marble are the ghosts of ancient impurities, minerals that were folded into the rock when it was still limestone deep underground, before heat and pressure recrystallized it. The lake then polished those veins to a shine. And the color of the water is not paint either. It is glacial flour, rock ground into powder so fine by ancient ice that it hangs suspended in the meltwater and scatters the light into that unreal turquoise. The cavern you would photograph today is not the cavern that existed a century ago, and it is not the one that will exist a century from now. Number 8. The Salar de Uyuni, southwestern Bolivia. It is the largest salt flat on Earth, more than 10,500 square kilometers of blinding white crust, the dried-out remains of ancient lakes, and it is almost impossibly flat. Across its entire enormous surface, the elevation varies by only a few centimeters. When a thin layer of rainwater covers it in the wet season, the whole thing becomes the largest natural mirror in the world, and the horizon simply disappears, sky above and sky below. In the dry season, as the salt hardens and shrinks, it cracks into vast fields of near-perfect hexagons and pentagons, a honeycomb stretching to the edge of sight. It is so flat and so reflective that NASA has used it to calibrate the laser altimeters on satellites in orbit, because it is a more reliable reference surface than the open ocean. And beneath that mirror lies a lake of brine, holding a huge share of the world's known lithium, the metal inside the battery of the device you may be watching this on. Walk out onto it in the wet season, and every step you take is mirrored beneath you, so that you appear to be walking across the sky itself, with clouds under your feet and clouds over your head and no line between them. Depth disappears. Distance disappears. Travelers describe a kind of vertigo, a sense that the world has quietly folded in half. And those hexagons underfoot are not decoration. They are the signature of salt drying and shrinking, and pushing its edges up into ridges, the same geometry that cracks a dry lake bed or a sheet of cooling lava, written here across an area larger than some countries. A mirror the size of a country, laid down by evaporating lakes, arranged by nothing but drying salt into perfect geometric tiles. Quick pause. If a formation on this list has genuinely surprised you so far, drop its number in the comments right now. We read them, and it tells us which of these places to make a full video about next. Number 7. Pamukkale, in Denizli Province, Turkey. The name means cotton castle, and from a distance, it looks exactly like a hillside buried in snow. But it never snows there. What you are looking at is a cascade of white stone terraces, brimming with warm blue water, spilling down a cliff 200 meters tall. 17 hot springs feed it, pushing out around 240 liters of mineral-rich water every second at temperatures that range from a warm bath to nearly boiling. As that water reaches the air and cools, it can no longer hold its dissolved calcium carbonate, and the mineral precipitates out, hardening into brilliant white travertine. The terraces have been growing this way for roughly 400,000 years, and they are still growing, adding new stone at a rate of just a few millimeters a year. The Romans built an entire city, Hierapolis, right on top of it, convinced the waters could heal. What is hard to fully predict even now is where the water will choose to flow next. Change the flow, and the cotton castle rebuilds itself somewhere new, 1 millimeter at a time. Number 6. Devil's Tower, Wyoming, in the United States. It erupts out of the rolling grassland like nothing else around it. A flat-topped tower of fluted rock rising more than 380 meters above the river below. Its sides scored with enormous vertical columns, as if a giant had raked its claws down the stone. The Lakota and other native nations have sacred stories of a great bear clawing at the rock. The geological story is that around 40 million years ago, molten rock forced its way up into the layers of sedimentary stone and cooled underground into this hard igneous column. Then, over millions of years, the softer rock all around it eroded away, leaving the tower exposed. But here is the honest part. After more than a century of study, geologists still do not fully agree on exactly what Devil's Tower is. Was it the plug of an ancient volcano? Was it a laccolith, a blister of magma that never reached the surface? A more recent study, in the journal Geosphere, argued it may be the remains of a lava lake that filled a volcanic crater. Think about what that means. One of the most recognizable rock formations in North America, a place so striking it became the first national monument in United States history, and the experts who have spent their careers on it still cannot fully agree on how it was born. Each of those enormous fluted columns formed the same way the hexagons at the Giant's Causeway did, by cooling and contracting, which is why the sides look raked. But the question of what the molten rock was doing when it cooled, whether it filled a volcano's throat, or pooled in a crater, or blistered beneath the surface, remains genuinely open. The claw marks are columns of cooled rock. What we cannot say for certain, even today, is what kind of volcano, if any, once stood here at all. Number 5. The cliffs of Moher, County Clare, Ireland. For 8 kilometers along the western edge of Ireland, the land simply ends, dropping straight down as much as 214 meters into the grey Atlantic. Standing at the top, with the wind trying to push you backward and the sea crashing far below, it feels like the edge of the world. But look at the cliff face itself, and you are reading a book. The rock is made of layer upon layer of sandstone, siltstone, and shale, laid down more than 300 million years ago, when this was not a cliff at all, but the mouth of an ancient river delta emptying into a long-vanished sea. You can still find the ripple marks of that river frozen in the stone, and the burrows of creatures that lived in its mud. Every band you see is a chapter of deep time. What the ocean is doing now is tearing those chapters away. The cliffs are retreating, slowly, as the Atlantic undercuts them and slabs break off and fall. The edge you would stand on today is not where the edge was 1,000 years ago, and it is not where it will be 1,000 years from now. Number 4. The Painted Desert, Arizona, in the United States. It is a bad land, a barren, rolling landscape of soft hills that stretches for over 260 kilometers, and it is banded in stripes of red, orange, pink, lavender, and gray, as if the ground itself had been dyed. The colors come from a formation of clay and mudstone laid down more than 200 million years ago, in the age of the earliest dinosaurs. Each colored layer is a different chemistry. The reds and oranges are iron that rusted in the open air. The grays, blues, and lavenders are iron that was buried and starved of oxygen. So the stripes are, quite literally, a map of ancient environments, layer by layer, stacked on top of one another. The strangeness here is how sharp the color boundaries are, and how they seem to shift as the sun moves across the sky. so that the same hillside looks like a completely different place at dawn and at dusk. The clay here is a kind called bentonite, and it swells when it is wet and shrinks when it dries, which keeps the surface constantly churning and refuses to let plants take root. That is the secret of the colors. Anywhere else, vegetation would cover the ground and hide the rock. Here the earth stays bare, and so it stays visible. Rain does not just reveal the stripes, it repaints them, dissolving fresh mineral and letting the iron flush red or bleed gray, depending on how much air the water carries. There is almost no plant life to hide the rock, and so the desert wears its entire history openly, a 200 million year timeline written in color, changing hour by hour as the sun moves. Number 3. The Eye of the Earth, a great ring of stone in the desert of northwestern Saudi Arabia, roughly 70 kilometers from the city of Tabuk. Geologists know it as Jabal Raya. It is a near-perfect circular structure, about 5 kilometers across, with raised rings of rock rising from the flat desert floor. And from above, it does genuinely look like an eye staring up out of the ground. When researchers first examined it, they raised the same possibility they raised for the Eye of the Sahara. Could this be the scar of an ancient meteorite impact? Its shape, its symmetry, its isolation all pointed that way. Teams have mapped it in fine detail, drawing geological charts of every ring. And yet, unlike many structures, the question of how it formed has not been fully closed. Some evidence points toward an impact origin. Some points toward forces rising from deep within the earth, the same kind of uplift and erosion that made the Sahara's eye. It is one of the clearest examples of what this entire countdown is really about. A structure enormous enough to see from orbit, mapped and measured and studied, and still, when you ask a geologist exactly what carved this eye into the desert, the most honest answer remains, we are not yet certain. Number 2. The natural stone arches of Arches National Park, Utah. In one small stretch of desert, there are more than 2,000 natural stone arches, the greatest concentration found anywhere on the planet. Not one. 2,000. Spans of rock, some wide enough to drive through, others delicate ribbons of stone, all standing in the same red desert. The reason they exist here, and almost nowhere else in such numbers, is a rare recipe buried underground. Deep below the park lies a thick layer of salt, left by an evaporated sea, and over millions of years that salt shifted and buckled under the weight of the rock above it, cracking the sandstone into long, thin, parallel walls called fins. Water and ice then went to work, freezing in the cracks, prying away flakes, until holes broke through the fins and the holes grew into arches. What geologists cannot predict is which arch is next. Every one of these 2,000 arches is somewhere in a life cycle, growing wider and thinner until one day it falls. Arches have collapsed within living memory, and the recipe is so specific that this concentration exists almost nowhere else. You need the buried salt to crack the rock into fins. You need a desert dry enough that the sandstone is not simply washed flat. You need just enough water to freeze in the cracks and pry them open, but not so much that it erodes everything into dust. Change any one ingredient, and you get no arches at all. Somewhere in that park tonight, a new hole is opening in a wall of stone, and no one knows exactly where. Number 1. Delicate arch standing alone in Arches National Park, Utah. Of all the 2,000 arches around it, this is the one the world knows. A single freestanding curve of orange sandstone, about 14 meters tall, standing entirely by itself on the open lip of a natural stone bowl, with the snow-capped mountains far behind it and nothing at all holding it up. No pillar leans against it, no rock bridges over to support it. It is a ribbon of stone balanced against the sky. And here is the thing that even geologists find quietly unsettling. This is Entrada sandstone. It is soft, it crumbles. You can rub grains of it off with your thumb. The same forces that built delicate arch, the freezing water, the wind, the flaking of the stone, are the forces that are trying to bring it down right now, tonight. The legs of the arch grow thinner every year. By every ordinary measure of how quickly this rock wears away, it feels like it should already be gone. Engineers have measured how it hums and vibrates in the wind, listening for the moment it begins to fail. There is a story geologists tell to explain how a rock this soft survives at all. The very softness may be part of the answer. Hard, brittle rock cracks under stress and shatters. Soft sandstone can flex ever so slightly, redistributing the weight, settling its grains, finding a new balance with every gust and every freeze. The arch is not rigid. It is quietly negotiating with gravity, moment by moment, and it has been winning that negotiation for far longer than it has any right to. And still it stands, this impossible thread of soft stone, holding its curve against the desert sky for reasons that come down to a balance so fine that no one can tell you how much longer it will last. The Paiute knew these deserts for centuries. Science has mapped every grain, and the single most famous arch on Earth remains, in the end, a structure that by all rights should have already fallen, and simply has not. So there it is. 15 places where the stone refuses to behave the way stone is supposed to. An army of limestone towers in China that split into blades before the dinosaurs. 40,000 hexagons in Ireland that a legend named before a laboratory could explain them. A granite wave in Australia carved in the dark, underground. A bullseye in the Sahara that everyone was sure was a crater until it wasn't. Frozen giants in Bryce Canyon, blades of stone in Madagascar, a glowing marble cave still being carved by every passing wave. A mirror the size of a country in Bolivia. A cotton castle of warm white stone in Turkey. A clawed tower in Wyoming that geologists still cannot fully name. The edge of the world in Ireland, a 200-million-year timeline painted across Arizona, an eye of stone staring up out of the Saudi desert. 2,000 arches in one Utah valley, each one quietly counting down to its own collapse. And above them all, a single impossible curve of crumbling sandstone that should have fallen long ago and has not. The pattern, if there is one, is humbling. We can date these places. We can measure them, map them, recreate them in the lab. And again, when we ask the last question, the one about exactly how, or exactly why here, or exactly how much longer, the honest answer from the people who study them for a living is the same. We are still not entirely sure. The Earth was making these long before we arrived, and it will keep making them after we are gone. Which of these 15 would you most want to stand in front of before it changes forever? Tell us in the comments. And if you made it all the way to number 1, you are exactly the kind of person this channel is made for. So subscribe and stay with us, because the Earth is not finished surprising us yet.